Hi, today I want to start a series about FreeRTOS, or the Free Real-Time Operation System used by the ESP32, and especially I want to talk about inter-task communication. And if we look into the FreeRtos API, then we can see there's many options we have for inter-task communication. First of all, we can use notification, but unfortunately the notifications are not implemented on the ESP32 yet, or maybe they never will, I don't know. And so we have other options like queues, and today I want to focus on queues, and we can use event groups, and we have to talk about what is an event group, and also we will have to mention semaphores and also mutex. So let's start today with queues, and as we know from our app main routine, we can start tasks with the API create task. So if we, for instance, create one task and then create another task, and we want to share some information between the tasks, then we can create also a queue, and one of the tasks can send some messages to the queue, and surely the queue have to be big enough to hold the stored information, and certainly we can also send more than one information or message to the queue. And so the task 1 can maybe store 1, 2, 3, 4 messages into the queue before the task 2 even tries to receive the message. And the other task then can receive all messages in a loop maybe, and one message after another can be computed by the other task. And if there's no more messages, the task 2 will be wait until the next message is sent to the queue. So the task 2 stops any activity and also don't consume any CPU resources. So let's have a look at the API and some chosen commands I will show today. First of all, we can create a queue with xQueue_create, and maybe if we want, we can delete a queue with vQueue_delete. And if you wonder why there's an X before or an V, because the writer of the API want to show how the return code is interpreted. So for the X, we know there's a special return type, and for the V we know the return is void. And with xQueueSend we can send a message to the back side of the queue, and we also can use the xQueueSendToBack function. And in opposite we can use the xQueueSendToFront function, and then our message is placed on the front of the queue. And to receive a queue message, we use the xQueueReceive function. And there are many more queue-related functions like reset to reset the queue, peek to look inside the message without receiving it. Then we can also use the ISR or interrupt-related functions. That's useful if our queue is filled or received inside an interrupt. And maybe we can also use the override function to override a already sent message. And now let's have a look into a simple example code. First of all, we have our header file just for the FreeRtos development and also the ESP header files, and this is some definition I've made to print out some colors so we can see the example better on the screen on the debug output. Now let's start with the main program. We just create a queue with xQueueCreate, and the size is 10 messages we can send to the queue, and we use the size of our message, and I only want to send some 32-bit integer unsigned to the queue. Then we just print out some informations about the memory usage. That's not really necessary for our example, but maybe it's useful to test some memory usage of tasks and queues and so on. Then we just create one task in this example for the start to send some messages, and we also create a receiver task to receive the message. And now let's have a look to the sending task. We just do an endless loop and print out some messages, and then we only send a message to the queue we created, and we only want to wait approximately 1 second to send to our queue. So maybe if the queue is full, we can't send to the queue, and then even after 1 second we failed to send our message to the queue. And then we also do some delay of maybe 10 seconds, and then the whole loop is start again, and so on. And now let's have a look at our receiver task. We skip the second task. The second task do just the same, but the only difference is we print out with another color. And so let's look into the receiver task. We also put out some message and do a endless loop, and the only thing we do yet in the loop, we just receive the message and print out the message. And again, we only want to wait about 60 seconds maybe to receive our message. And then we also have a timeout. In this case, we only print out that the receiving of the queue have failed. So that's all. Then we just compile our example. I do it with the command line, so don't be afraid. The command line is also your friend. You don't only use Eclipse. So I just do a make flash monitor, and this also compile if necessary our code. So the program is compiled and flashed to our ESP32, and now we start the output. And as we see, we start a transmitting task, and we send the message 0, and the receiving task is also started and receive the message 0. And then we delay 10 seconds and the game starts over and over again. We receive the message, then we send the message, and we receive the message immediately. And the transmitting task is delayed, but in the receiving task we have no delay. We just wait for the next message. So we can stop this example here and go to our code again. And now I want to start another task, and the task is just the same. We do an endless loop and send our message to the queue, and don't wait 10 seconds. We only wait 7 seconds. So we have some different delay time. So let's flash it again and start the output. And now we see we start one task and the next task, and we receive 2 messages. In the start they are all the same. We transmit one message from task 2 and receive it. We transmit a message from task 1, receive it, and so on. And after a while, maybe the task 2 is faster than task 1, and we see that we receive 2 messages from task 2 before we just receive 1 message from task 1. So stop here. And now we do another trick. We introduce a delay in our receiving task, and we only delay if the message queue is empty. So we call a special function. We ask how many messages are waiting in the queue, and if the message queue is empty, we get 0. And if we get 0, we delay for 15 seconds. So let's save our example and flash again and look at the output. So we start again with one task and the next task, then receive the 2 messages, then our sending task sends the message, then we send the message, but our receiving task is not ready to receive because we are sleeping for 15 seconds. And after the wake up, we just receive more than 1 message because every message we send to the queue is received in 1 block. So that's all for today, and I hope you learned something and enjoy the video. And all the code examples can be found in GitHub. I put a link in the description down below. So I hope you have a nice day, and bye bye.